All right, ladies and gentlemen, today we're going to be applying the log properties that you learned in the last video. So here's a quick do now. So we know that the exponential functions and logarithmic functions are inverses of each other, so we're going to fill in the table below. So here you have 2 to the x. Well, its log function is log 2 base x. So then let me erase the highlighter so you can see what happened. Uh, Whatever the base of that exponent is, that's the base of the log. And then whatever the exponent is, that's what goes inside the log. So we can reverse engineer. Log base 4x, well, there's your exponent and there's your base. So this would be 4 to the x. And now we just reverse engineer everything. This would be log base 3 with an x inside of it. This would be 6 to the x. Now 10x is special. This would be log base 10 to the x, but that log base 10 can also be written as just log x because log base 10 is kind of like a mini identity, so 10 can be invisible if you want, okay? And it's okay, on exams or on the AP exam for next year, you can leave log base 10 as just log because the graders will understand what you mean. Just make sure you understand. Just make sure you understand. Okay, now the inverse of the natural log is e to the x. Okay, so that means e to the x and ln of x cancel each other out. Okay, all right. Please make sure you pay attention to this right here that I'm currently highlighting. That is super important. I'll zoom in so you can see. If the base and the inside of the log are exactly the same, then that exponent is your answer. And if you have like an exponent like b with an exponent of log base b, so again here b and b match, then whatever is inside that log is your answer. So now that we know the inverses, we can see when they're placed together. So for example, log base blank to the 10 squared, well, that's still log base 10. So see how they match? So match, match. That means that 2 is my answer. Okay. ln of x, ln and e are inverses of each other. So this and this cancel, and therefore your answer is -3. Okay, because they're inverses of each other. If you put an e inside of a natural log, it goes away. Now here we need to do a little bit of work with this one. All right, there's a negative in front of the natural log, and just remember this is an exponent. So this can be put on the 2. So then you have 6 e to the natural log of 2 to the -1. Well, that we just put an e and a natural log together, so those cancel. So now it's 6 times 2 to the -1, which is just 6 times 1/2 because negative x when it goes down, which is just 3. All right, next one, we have 5, 2 log base 5, 4. So remember, this part in parentheses is an exponent. Well, same as before, take the 5, since it's in front of the natural log of the log, and put it on the 4. So this is 5, and then log to the 5th 4 squared. But now we see again, like the inverse rule up here, okay? We see a 5 as the base and then a little 5 in the log. So then now those cancel. You're left with 4 squared, which is just 16. Okay, we can keep on going. So right here again, negative goes over to the 4, becoming an exponent. So 2 with, not the negative and the 3 go up there. So all this. So this would be log base 2, 4 to the -3rd. Well, now again, we see these two match. So because they match, the answer is 4 to the -3rd, which is just 1 over 4 to the 3rd, which is just 1 over 64. Okay, and then finally this one, again, log base 10. We can rewrite that as log base 10, and then inside 10 to the 3rd. And then this one can be rewritten as 3 log base 3, 2 to the 4th, because again, this one can go up. I rewrote this as this. And then now, here we have matching tens. So because those two match, we have, oh, sorry, the answer is just 3. Minus, here we have the 3's matching, so this and this matched. So now our answer is just 2 to the 4th. So it's 3 minus 16, which is negative 13. By the way, I know I've just been using the 10 to the 10, but as long as the base and the inside are exactly the same, the answer will always be, they'll always cancel out. So for example, let's say log base 5, 5 squared, the answer is 2 because the 5 and the 5 cancel. Let's say log base 3, and then base 3, there's a 10 in there. Well, the answer is 10 because the 3 and the 3 cancel, and so on and so forth. Okay, so as long as the base and the inside are exactly the same, you have yourself an answer. Okay, now we're going to solve this one together, and the next page has a whole bunch of these. So here we go. Alright, so let's get started. So then we have log base 2, 2m plus 1 minus 2 log base 2, 3 equals 1. Well, I'm going to move, let's say I'll do it in a different color. I'm going to move this 2 over to its exponent right there, and I'm going to keep the negative right here because that's going to be how we divide later. So let's see what we got. Now we have log base 2, 2m plus 1, all right, minus log base 2, 3 to the squared power, okay? And that all equals 1. Now, because we have this minus sign right here, I can combine these two with division. So it's going to be log base 2, and then 2m plus 1, all divided by 3 squared. That's in parentheses, and this equals 1. Now we can use the circle of logs to our advantage. Remember, the 2 moves over to this side of the equal sign, and then the 1 goes as its exponent. So this ends up being, and the log disappears. So 2m plus 1 over, let's just write 9 now because it's 3 squared, equals 2 to the 1 power. Okay, because I'll do it in green. This and this combined to form that. And then what I'm highlighting in purple stayed put right here. Okay, so now we can easily solve this using algebra. So we have 2m plus 1 equals 2, and then this is over 9. Multiply both sides by 9. So you get 2m plus 1 equals 18. Subtract 1, so now 2m equals 17. And so m equals 17 over 2. And we found our answer without using a single calculator. All right, so you guys will do the next page all on your own. Well, of course, I'll help you out tomorrow if you need help. So have yourselves a wonderful evening, and I will see you all next time.